Hi, and welcome to Tremco Live, where we're socially distant but technically connected. I'm Marcy Tyler, one of your hosts, and I'm the Director of Building Science for Tremco.
And I'm Paul Hugenman. I'm the President of Tremco Construction Products with Marcy, a tremendous collection of brands, products, systems, companies, and most of all people.
Most of all people. Love being able to kick this off every Friday with all of you, bringing you different content. And if you haven't noticed, our venue's changed today.
Yes, it has. I've not been here since, I think, 14 or 15 months ago.
Yep.
Right before the pandemic.
I think our last tour was in March or late February.
Yeah. We used to be here, I don't know, weekly.
We were here weekly giving tours, and that's where Tremco Live came from. The birth of Tremco Live was because we couldn't come here and meet regularly with all of you.
Yeah, so now we're going to be able to both come here and do Tremco Live.
Exactly. So this month, in the month of June, we're kicking off everything about testing. So we're going to go to different locations. We're going to talk about different types of testing. And we thought we'd kick off the month by bringing you back here, back where it all started, at our Building Science Laboratory.
I have so many favorite places, but this might be my most favorite.
Yes, his favorite. He's got a lot of favorite products and systems, and then favorite places too. Yeah. So when we're able to start doing tours again, which is hopefully soon and in person, one of the places we went to was this facility here, kicking it off 7:30 in the morning with a great presentation. And I think everyone's favorite thing was being able to look at the testing, the equipment, and all the assemblies that were around us.
Yeah, I think there was always a great wow factor when people come here because one, the fact that this even exists. Two, that our message, you always start with a message of this is as of today, this is your facility. And then of course, I know we're going to go around today and look at some of my favorite test box.
Yeah, exactly. So just like Paul stated, we wanted people when they come here or when you're watching it like you are today to feel like this is your place to come and do testing. So as we're walking around here, if you have a design challenge, if you have something you've always wanted to test or validate, that's exactly what we want you to be able to do. Reach out to your Tremco rep and let's figure out a way that we can engage with you here at this facility.
Yeah, and the other thing we like to share is that we also think it's the best practice for as you design, whatever your new facility is, that always come here to validate before you go build it.
Absolutely. We want to get ahead of things before we get to the job site. So this is a great opportunity for that. I know we've gone through a bit of evolution with testing with this facility. We started off with just doing air testing, right, down in Ashland.
Yeah, what year? 2010?
2010, yeah.
Long time ago.
It was, yeah. And so it's great. When you think about it, we've been doing this type of testing for 11 years, and it's evolved as the industry has evolved in terms of its knowledge and its questions. The biggest question we got when we did air leakage testing was moisture. People wanted to know, they're like, okay, great. Well, what about water? Because people aren't calling you and saying your building's leaking air. It's because they're getting moisture-related damage, which could be caused by air. But we wanted to be able to do water penetration testing too, which is why we ended up in our Mamico facility in this area where we stand today.
Behind us now, the original test wall here, I just learned is moved on.
It's moved on. It's got a different purpose today. So we had a smaller area where we did tests, so we could do your 8x8 test assemblies, which is what's featured behind us today. But we couldn't go bigger than that. So we wanted to go bigger because as we did that area, the question people asked was, what about the roof to wall? Exactly. The roof to wall, the window to wall, the transitions. And people wanted bigger and bigger assemblies. So that's why we decided to use this facility, this space out here to expand our capabilities, go higher, go larger, and get really even more creative with the design challenges and how we can validate them.
Yeah. So, of course, you're going to share with us today, too, that when people talk about go bigger, we had to go so big, we needed to put a big door into the side.
We had to put a huge hole in this facility in order to get one of the test assemblies that are here. And so we're not beyond doing that, taking walls down, making changes, and listening to people like you ask us those questions. So, Paul, behind us today, once again, we have multi-directional blowers. That's an advancement from our early days. We only were going in one direction. It took twice as long. We had to flip the samples around. Now we got positive and negative pressure going. We can cycle it. We've got air leakage, which is a certain test method, which is ASTM E283. We can also do ASTM E2357, all related to air, wind loading. We can customize all of that too, depending on what you want to look at, what kind of wind loading you're going to see on your building. And then the fun starts.
Yes. I think the expression I like to use a lot is test the failure.
Yep.
So we like to see how things break.
Mm-hmm.
And the word I always use is we want elegant failure. And I think the metaphor we like to use a lot is if you pull on a thread of a sweater, if the whole sweater comes apart, we call that inelegant failure.
Yeah, you don't want that.
Catastrophic.
Yeah.
And what we really want is something that fails on a very localized level.
Yeah.
It can be easily identified and repaired. And it's only through test of failure that you actually see what the failure mode is.
Yeah, exactly. So if you want to do that, if you want to test those design parameters to failure, that's what we like to do here. So imagine, if you will, your air pressurization that you would normally require of a mock-up or even your building. We can go 4 times as high as that. And why would you do that? So we can find where those weak points are, where those points of concerns might be. It's great for the entire design team. It's great for everyone involved on the project. It really is helpful to understand where those points of concerns could exist, because once we build this on our projects and cover it up with a facade, what do you got to do to get back to that?
It's very, very painful, and in many cases you simply can't, right? It's the best case scenario is either total replacement or something that's far less than what the original owner envisioned.
Exactly. So think about that, right? If you're putting down a coating on a parking garage, there is some maintenance you can do. If you're putting sealants in joints, there's some maintenance you can do. There's a lot of maintenance you can do on a roof as well, right, in terms of restoration. But when you're putting up an air barrier, and if you're detailing around fasteners, there's not a lot of maintenance you can do there when that facade's in place. So we want to get it right the first time. We want to make sure it's robust, resilient, and that's where all of the testing starts here.
Yeah, we have some great examples, Marcy, on brand new buildings that have issues. Yeah. They're in litigation. And oftentimes Tremco becomes sort of a savior because we have great restoration.
Yeah.
That should have been happening 30 or 40 years later.
Yeah.
That can be used on initial construction if necessary. But to your point, it's a lot better to do this first.
Exactly. So whether it's a new construction or restoration, let us know what you're looking at, and we can go ahead and validate it. So, Paul, we've been doing this.
We're going to talk to him about remote validation, right? Because I know we're still, people might not be comfortable traveling. We have great case studies of where we did the validation for somebody. They were remote.
Yeah.
So you don't actually have to come here.
Exactly. And we did that even before COVID, right? So, if you are geographically, farther away than Cleveland, Ohio, I mean, who doesn't want to come to Cleveland, Ohio? But, if you aren't able to come here, absolutely right, Paul, we can do it virtually, right? So we can engage this great team of individuals that are working here to share with you virtually as much as you want to share or see or be a part of throughout that testing process.
It can also be a great learning tool that way, right? We now, especially last year, become really comfortable with all kinds of virtual training and everything. So not only can we run the test for you, but if you're an organization with many locations, it can all come on.
Exactly. And I've done a couple of those. We've done a lot of tours virtually for different organizations, walking them through our capabilities here. We even set it up so it can be AIA accredited as well as IIBEC. So we can speak generically in terms of testing technologies. We're looking at a couple new things coming up in the next couple of months in terms of education, doing some sort of live testing. If you have some facade anchors you want to test and validate, we can do that as a program, give you some hands-on materials at your location, and then do a lot of the bigger scale testing here and have it be virtual.
Yeah, and I think the other thing we're working on, my understanding is we're in the home stretches, sort of like in the Harry Potter movies, whatever you can fly through.
Yeah.
We're doing the same. We're bringing the same technology to what we're doing here, so that you can really not only have a virtual experience, but really be in a 3D sort of scenario, be able to be present, walk through. I'm excited about that.
Yeah. So imagine you are seeing us today, but you would actually be able to move through and focus on what you want to focus on. As you turn this way, you'll see that area. So I know we're started with one of our plants, and our goal is to continue to go through a variety of our plants, and of course this facility here. What's really cool, since this is part of one of our plants, just on the other side of one of these doors here, we're making things like Dimonic 100, all of our Volcom coatings, our Tremproof, some of our Tremproof products. So being able to see how it's made, I know it's always a really cool thing for me. It's always been a key part of our tours, and we really wanted to be able to bring that to everybody virtually as well. So really interesting here. Like I mentioned, we're doing air and water leakage testing. We can customize it to your specific assembly. What you're seeing behind us right now is a great prototype product, Paul, that's going to be launched in a couple months. It's a really cool new air barrier, so stay tuned for that. We're very excited about that. This is a typical assembly. We've got a wood buck window. We've got different types of penetrations. Now, a wood buck window is very easy to seal. What about the window you're using on your project? That's where this facility comes into play. Let us know what type of window you're looking at. Let us know what type of connections you want to do, and let's validate it and test that connection versus what's called for in this. Now, what's great about this is it's going to isolate the air barrier material. We're going to isolate that. We won't have to worry about maybe the window leaking. We do have issues with the actual buck leaking. That's what happens, Paul. The air pressurization we're working on here causes the water that would be cascading on the surface to make its way around the assembly and through a knot in the wood. That's insane.
I think the other thing we do here, unless you see it, it's hard to appreciate. I think we run, 8 inches an hour?
Yep.
So there are those rain events. Many walls can withstand a normal rain event, but when it rains so hard that you have a continuous sheet of water, that's really what our 8 inches an hour does, is mimic that extreme event, and that's where we see a lot of failure.
Absolutely. So just as Paul mentioned, we want to get that continuous film of water. So we're putting in an enormous amount of water on these wall assemblies, more than it will ever see. Because imagine there's generally a facade in front of it, protecting it from some of that. But once again, at this stage of your construction project, we want to make it worst case scenario. That's what is that 8 inches of water. That's what ramping it up to higher pressure differentials that maybe that air barrier or that assembly will never see. And then we can also add in your actual windows or your facade if you want to see all of those steps along that process.
I think, 8 inches an hour, they used to call that a 100-year event, and it seems like 100-year events happen every year.
Yeah, they are definitely happening lately.
100 years.
Yeah. So once again, if you have something you want to test, something you want to take a look at, we have some standard procedures, but we can customize it. Do those wind gusts that you want to see, understand the wind loading that you're going to have on your project, and even extend the duration as long as you want to be able to see it. Want to take a look at a couple other things, Paul?
Is there anything new here?
We got a couple new things here, and we always like to show some assemblies. So let's take a walk over this way a little bit here. So, Paul, as you know, we're really excited about New Brick. Yeah. So we've got a lot of different things that we're looking at as it relates to our Drive-It product. This is an innovative approach to our lightweight insulated veneer, which is called New Brick. So more to come on that. So we've got some cool, innovative things as it relates to this installation.
Yeah, this is the installation of that prototype.
Yeah.
Very exciting. I know you forbade me from using the name.
Just not yet. Just not yet, Paul.
Not yet. Okay.
Not yet. And then we also have this is just our backstop NT. That's another an air barrier material with Drive-It, and we're just doing some testing with this material, rolling it outside. We've done that a lot with some of the air barrier materials we tested in the past, Paul, right? A while ago, we had, I think, 8 different assemblies, different types of air barrier technologies. It's great because we take them outside, weather them, bring them back in, test them for air and water leakage. It gives us a great understanding of how these products are going to perform during the exposure period during construction.
Yeah, I think people a lot of times underestimate the exposure period, either in initial construction or then you get job delays.
Yeah.
So that exposure is, I think, a lot more important than people realize.
And that's where we like being able to do that sort of thing here. If you're interested in knowing what we've done as it relates to those air barrier weathered assemblies, that's where you can reach out to your Tremco rep or myself, and we'd be happy to talk to you about that. Once again, it's been 10 years in the making of all this different types of tests we've done here, and we're going to really kick it up a notch in terms of sharing with you all what we've done here, what lessons we've learned, and we are always looking for partners out there, people to collaborate with us, to come here and test, and then you'll be able to use that information to educate others. We also, right here, have a test mechanism that we're looking at, another one of our products, which is Will-Seal. So this is those pre-compressed foam tapes. So adding to our capabilities of coatings and membranes and sealants and air barriers and, of course, exterior insulated finish systems is now another key part of connectivity, having these pre-compressed foam tapes from Will-Seal.
Yeah, this was interesting when before we started to broadcast, Marcy, you walked me through this. This is us innovating. Okay, what is the right way to test this? I mean, we know the basics.
Yep.
So this is some of this innovation that you see right here is, well, how do you test? And we're really innovating and creating the test.
Yep, exactly. So having all these additional systems and knowing how important connectivity is also, once again, the root reason why we have this facility here and why we open up the door to all of you. Now, Paul, as I mentioned early on, when we were only testing air, people said, what about water? When we started testing for air and water in the back area here, they said, well, I want to go bigger. I want to test for all those connections on my job site. But then what did people start asking us for?
Well, I think thermal.
Yep, they wanted to be able to, one, address different temperatures, two, introduce different levels of humidity, three, add different ports within that assembly so we know exactly what's going on in each of those layers of our assembly, and of course, they wanted to know more about thermal resistance.
And it surprised me at the time that thermal wasn't, I guess we'll call it a standard. So we're really working closely with some key industry partners on what those standards should be.
Exactly. So that is where we come to what we now have behind us, which is our thermal environmental chamber. So we've got two areas here so imagine being able to have an interior climate, whatever that might be, and an exterior climate, whatever that might be. You can dial it up and down on both sides. So two environmental chambers, and in the middle is your assembly. So everything we were able to do in our other wall that we started off with today, now we can actually control it in a controlled environment, dial up the temperatures, dial up the humidities, introduce the air pressurization as we did before, all the way up to 1200 pascals. But we can also then have those data points to understand what's going on in each of our layers and get that overall thermal resistance of that entire assembly as a whole.
I can only imagine what we're going to learn, especially in the first couple of years. Very exciting. What was this, 3 years in the making?
It might have been more than three. Might have been more than three. But we're excited that it's finally arrived here. The team that's working here, Phil Effler and Sergio Gonzalez, are really going feverishly at getting this up and ready to go. We can't wait to launch all the capabilities of it. I think one of our first ones, Paul, just to kind of get a baseline, is just going to be comparing a wood stud wall to a steel stud wall. And then adding the attachments for insulation and facades, and then doing it with our products from Dryvit. So really being able to compare what that looks like from a entire assembly perspective. Now, I know there's modeling out there like Woofy. Woofy can help us analyze where we might have issues with dew point. I know there's different ways that we can get that thermal resistance of different materials. But what happens when it all comes together? We want to be able to do it live and in person. And then once again, the great team that's working here is also going to be able to simulate it so you can visually see what we're actually producing here. So there's so much more to come here. As Paul mentioned, we're working with Oak Ridge National Lab, the Department of Energy, who has the sister equipment to this. So we're really excited about working with them, collaborating with them, and really educating the industry with our findings.
Big shout out to Oak Ridge, right? Yeah. They're really the thought leaders behind this.
Yeah.
And we're standing on the shoulders of everything they've learned.
Yeah.
What we put together.
So imagine, initially we thought, let's do what is called a guarded hot box. Now that can give you that thermal resistance, but it can't give you all those other environmental changes that we want to be able to see too. So once again, it would have been a separate thing, right? We would have been able to do air and water leakage in our other area, get our thermal resistance here. Now we can do it all in one space with one assembly and really be able to get that understanding. So we can't wait to be able to share that. And it's even more relevant in our space today with energy efficiencies, with sustainability, with durability, but also because we're so excited about all our capabilities that we've added to our portfolio with our Dryvit materials. So what we're standing behind, what is behind me today, is several of those finishes that we offer by having Dryvit as part of our portfolio. So really excited to have this capability, learning so much about the Dryvit portfolio and all the great features and benefits, and also to be able to test it, not only just for air and water, but the great benefit of that true continuous insulation without any mechanical attachments and what that's going to do for your project. It's really incredible.
I think, Marcy, with the huge shift to panelization, this will just become that much more important.
Oh my gosh, yes. Which is ironically, majority of the samples that are behind the wall are lots of different types of panelizers that we're working with directly. So if you're a panelizer and you want to take a look at your system, your assembly, that's another opportunity for us. You know, what's great is these panelizers build and then ship to the job site. So it's the same thing that happens here. They build, they ship it to us, and then we validate it and we take a look at it. Pretty exciting.
I somewhere behind this is one of my favorite books where you have all the different attachment methods. So there's still a lot to learn about attachments.
There is. Yeah, what Paul's speaking to is some of our assemblies that we bring in that are project specific, or maybe just you validating a variety of different facade anchors. That seems to be the most popular, right? Because we know that we're going to put up an air barrier. We're going to do a great job paying attention to the detailing and the transitioning, but then we're going to poke a million holes in it,
right,
because of the insulation and the facade. So we want to make sure that what that air barrier product is robust enough to handle those threaded fasteners, to handle the load of that facade, and we can do that here each step of the way. It is our most popular test where we've probably spent the most time, and that is why we are so aggressive when it comes to our air barrier products, their thickness, and their ability to gasket around fasteners.
A lot of counterintuitive results, right?
Exactly.
What your eye tells you may not necessarily happen, is what happens when that sheet of water hits.
Exactly. So, and of course, just to kind of round off our broadcast we couldn't end today without talking about insulated concrete forms.
So, Marcy, what is this right here?
This is insulated concrete form from Nudura. So we're really excited about this new addition as well to our portfolio of systems. It comes with very innovative system approach and a lot of great people.
This is what, 8 foot in length? You said it's actually taller than me.
We found something taller than Paul.
Of course, if we tilt it, right?
Yep.
That's one of its key features is that it actually compresses.
Yeah, so it actually folds flat for shipping. So that it's going to save a lot of space from a shipping perspective. So you're not shipping air. Another question we get is like, oh, do I have to put this together on the job site? No, because it's shipped flat and you just fold it open. It's 18 inches high, 8 feet long. It's going to really help with productivity. From an installation perspective, it has a locking mechanism. So, you know, as you lock each of these on top of each other, they're going to be held together because of that locking mechanism.
Probably there's 20 or so features just on this little block, but
there is.
We're a little tight on time. So.
Exactly. So if you haven't checked out the Nudura insulated concrete forms, we have a couple episodes about it and a lot of great information online. But we definitely are excited about that capability of testing what is that true thermal resistance, what is that true thermal mass that we're achieving by putting concrete in the center of this. And we're really looking forward to adding that to our testing as well.
Yeah, I think the thermal mass data, I think it's, we've commented on that in the last year. I think it's just really emerging, the understanding of the importance of thermal mass, but more importantly, the benefit of thermal mass. So I think the Nudura testing, Marcy, is going to be really exciting.
It is. So, so much we were able to show you today. This just kicks off our month of testing. I'm really looking forward to all the rest of the Fridays in June to be able to take a deeper dive into different testing as well as different testing locations. But that'll probably do it for us today.
Yeah. Well, thank you for inviting me back.
Yeah.
And I guess I look forward to being back frequently.
We definitely look forward to that. So thank you so much for your time and attention today. That will wrap us up on our June Tremco Live.